So in previous lectures, we have gone through the concept of MOSFET, basics of MOSFET, which is the fundamental for the all the topics. Secondly, that is the channel length modulation. So effect of channel length modulation we have seen. And third topic, we are going to see the body effect, which is very important. And every time from the first lecture, I'm telling you, this is the body effect concept. We will be studying this afterward. So that is the thing, that is body effect, that we will be studying in this lecture. So we are starting channel body effect. That is after the completion of this particular point, student will be able to correlate and interpret the concept of body effect with respect to MOSFET performance. What is the effect of body effect on the performance of MOSFET, that we will be seeing over here. So I'm putting into the presentation mode over here. Okay. Now, before going to this body effect, I just want to elaborate some introduction. As you know, this MOSFET, that is metal oxide semiconductor field effect transistor. So this is the P substrate where I have drawn this type of MOSFET, N type of MOSFET. And this is a P substrate, which is also called as a bulk or body or substrate. So I have given three names, which are that bulk, body, and substrate. All the names are same, that is for the body only, or substrate is nothing but a body, nothing but a bulk. So here is the source terminal, here is the gate terminal, and here is the drain terminal. If I have to see this particular structure, whenever I am giving positive voltage to the gate, as there is a formation of capacitance over here, there is a near to the surface negative charges are created, and that's why there is a formation of inversion layer. So now if you are seeing this particular structure, are you able to see this gate? And this is body. No N plus doping is there. So pure N P substrate and metal and SiO2 layer is over there. So are you able to see how many types of material are present? You have studied in the starting, in the first year, metal, semiconductor, and insulators. So all the type of material is there in the MOSFET. Just listen properly, understand it properly. So here there is a metal also, here there is an insulator also, which is bad conductor, this is good conductor, and this is semiconductor. In between that you are having. So if I'm considering energy band diagram for this, energy band diagram means whatever the Fermi level, whatever the conduction band, valence band. So in metal, what happens? Although small amount of energy is given, then electrons from the valence band move to the conduction band and they becomes free. But in insulator, you need to apply more energy so that some part of electrons will become free, will go from valence band to conduction band. But that is very small. And in semiconductor, it will be moderate. So here, this metal, which is previously was of aluminium, now we are using polysilicon over here. Polysilicon is the conductor and it is a polycrystalline material. Okay. Second, you are able to see that is the insulator. Which type of insulator we have used over here? That SiO2, silicon oxide, silicon dioxide. So here SiO2 material is present here, which is the insulator, and it is amorphous material. What is meant by amorphous? That this material is SiO2 here. It might be a air. So we can't predict the size or type of that material. So that is the amorphous. And last is the semiconductor, that already you know, silicon Si material, and it is crystalline. So all type of materials and classification of different types of metal, non-metal insulators are present in this structure. So this is just for an introduction to have a knowledge. Now, going forward, as I told you, this substrate is also called as a body, is also called as a bulk. So this effect is also called as a substrate bias effect or body effect. Now, from starting lectures, I am telling you about that source is connected to the substrate every time, and it is denoted by dotted line. Why we require source to be connected with the substrate? And here specifically, instead of writing substrate as a S, here instead of writing substrate as a S, we have considered it as a bulk, that is B, and here it is denoted by S. So this is my bulk and this is S. Now here we have considered that, as you know, that there are two types of voltages present over here, that is the vertical field and horizontal field. And if you are considering this source is not connected to body, so your VGS will be, VGB will be different than the VGS. This VGS will be different than VGB, because if bulk is connected to different potential, then my voltage will not be same. So we have to consider every time whenever we are operating this MOSFET, we have to consider VGS is nothing but VGB, because we are connecting source with this bulk. And second, VDS voltage, drain to source voltage, and here we have considered source is connected to bulk, so it is at the same potential, so it is same as the VDS. So VDS is nothing but VDB. So hope these things are clear. Now why we need to connect body to the source? That is the next question that I will tell you in the coming PPTs. Now in this particular symbol diagram also, I told you that this dotted line indicate the source is connected to substrate or body. In P channel also it is connected like this. Now in an integrated circuit using MOSFET device, there are thousands or millions of transistors, and if thousands of transistor means there are thousands of sources, so source terminals are there, but there is only one body, that is silicon substrate. Meaning of that, if I am considering this NMOS PMOS structure, this is nothing but NMOS PMOS combination means CMOS, but I'm not going towards the CMOS. But here there is only one substrate in which all the MOSFETs are designed. So there is no different substrate present over here. So that is the meaning of this, that as the number of MOSFETs in this are more, the number of sources are that many, and they are in the single substrate, that is substrate is same. Now connecting all sources to a single body would result in an useless circuit, which introduces body effect and which make transistors slower and deviates from the ideal MOS characteristic. Definitely this is not a good thing to have a body effect, means there is having certain influence of that, or there is a certain effect of that on the MOS transistor. So this particular thing just I want to elaborate. Consider there are two N transistors. Here I have taken only N transistor. So this is N transistor and this is N transistor. This NMOS, NMOS. They are connected in series. Okay. This N MOSFET is connected to this another N MOSFET in series. Now, after connection, this is VT2, that is threshold voltage of this transistor 2, and this is the threshold voltage of transistor 1. And all the names are shown over here, that is VDD, base, drain, source. Now, suppose here mentioned the body is same, and if you are connecting body to the source, it will create a useless circuit. So suppose this is also a B1, and I am connecting this point to this source, and already here this is connected to this. So what will happen? This particular transistor is connected to source and which is connected to ground. So I can say VSB1 equal to 0. But although I have connected, although I have connected this body to this source, this is not grounded. Certain voltage is present over here, because this is having certain voltage. From this to this, there is certain voltage, and that's why I can say this is not equal to 0. And because of that, what happens? That there is a change in threshold voltage. Previously, suppose I am saying threshold voltage is 0.7 or 0.6 for transistor, and if I am taking same transistor, same type of transistor, so threshold voltage for transistor 2 and threshold voltage for transistor 1 should be same, that is both should be 0.7. But because of this body, what is happening? Threshold voltage of this transistor increases, and this transistor will remain 7 only. And when we need to work this transistor, this circuit, what will happen? If I am giving 0.7, what will happen? This will turn on, but this will be off state only. And this effect is due to the body effect. Because of body effect, threshold voltage increases. Threshold voltage of transistor increases. As threshold voltage increases, meaning of that, you require more voltage to create an inversion layer. And as you require more voltage, means what happens? That efficiency means transistor performance degrades. And for more voltage, you will be getting some current. So what is body effect? That because of body effect, there is certain VSB voltage present over here. That is, we can say body is not connected to proper ground potential or source. So there is a increasing threshold voltage. That is called as a body effect. So this will be I will be elaborating more in the next PPT. So here, just see, I have told you everything related to this. Now moving toward this, to have a detailed thing related to body effect, just consider this diagram. This I have already told you or shown you in the channel net modulation. Now consider that Vs is grounded and Vd is also grounded. Okay. Now what voltage you have given? You have given voltage Vgs equal to Vt 0, which is equal to 0.6. So at start also in last lecture I told you about VTO. What is VTO? It is a threshold voltage considering body is grounded. So here I have considered body is grounded, and that's why it is mentioned as a VTO, and it is 0.6. Here this is 0 volt and this is 0 volt. So now what is happening? Whenever we are applying source 0 and gate voltage as a 0 and VTO equal to 0.6, there is a formation of capacitance. Because of capacitance effect, electron will get attracted near to the surface, and there is a formation of this inversion layer. So there is a formation of this inversion layer. Okay, and as this body is connected to ground, that is zero potential, what will happen? Holes will get attracted towards this ground potential, because similar charges, negative repel each other, and opposite potential attracts each other. So positive voltage will attract electrons and negative voltage will attract holes. So here, as I have given zero voltage, what will happen? Holes will get attracted over here and electrons will get repelled, and that's why there is a formation of inversion layer over here. Now in this case, consider what is the difference I have mentioned in this figure and this figure. So here, instead of having VB as a 0 volt, 0.1 volt is mentioned. Now just tell me, as the device is same, this device is same, having same parameter, same manufacturer, that's why 0.6 voltage is threshold voltage over here. But because of some problem, some person has given bulk voltage or bulk potential at 0.1, what will happen? This is positive potential, and that's why electrons will get attracted from surface to bulk, and that's why number of electrons near to surface reduces. So at 0.6 voltage also, the inversion layer is not complete. So I need to create an inversion layer, means I need to increase this threshold voltage. So what happens, as I am not connected bulk to the source or bulk to the negative potential, what happens? Because of some positive potential present over here, electron from this surface will get attracted towards this substrate, and there is a reduction in the inversion layer. And to create whole inversion layer, I need to apply more VT. So this is the effect of body effect. What is the meaning of body effect? Because bulk terminal is not connected to proper potential, what is happening? There is an increasing VTO or threshold voltage. This is called as a body effect. So here it is mentioned the body effect is the change in threshold voltage. It is change in threshold voltage by the amount approximately equal to change in substrate to bulk voltage. By the amount approximately equal to substrate to bulk voltage. Now this can be defined by this particular equation. Now how to remember this equation? First thing, whatever the notes I have shared, that is the Word file or PDF file on the Moodle. So I have mentioned some wrong formula over there, so make it correct, and how to finalize that this particular formula is correct or not. I am giving trick to that. Before going to that, this is my ID current in the linear region, and this is the saturation region. Now how this body effect affects this current? Now, as body effect is related to change in threshold voltage, and this threshold voltage is coming over here also. As this increases, means this is also increases, and that's why this particular value decreases, and that's why your ID decreases. So because of body effect, I can say my drain current decreases. Is it clear? As there is a body effect, your VT increases. As VT increases, this is playing a role over here in the drain current, and as this increases, your value of ID current decreases. So in this way, body effect affects the drain current. Now, what is meant by this formula? So at start, I told you there are different types of materials used, that is metal, semiconductor, insulator. So this particular phi f, are able to see this phi f, that is the Fermi potential. It is related to that energy band diagram concept. So we are not going in the details of that Fermi voltage, but just remember over here Vt. What is Vt? Vt by considering the body effect, and this VTO means without considering body effect. When body is connected to ground, whatever the voltage, threshold voltage is there, this is VT0. And because of body effect, there is a change in threshold voltage that is defined over here. So VT, because of body effect, is equal to VTO, that is without body effect, plus gamma. What is gamma? Gamma is the fabrication constant, means what type of concentration, dropping concentration is there, that is mentioned by this gamma for NMOS and PMOS. Now plus gamma in bracket under root of 2 phi f, that is Fermi potential, plus VSB minus under root of twice phi m. Now how to remember? Now suppose if VSB is connected to 0, means there is no body voltage is given in this case. So what will happen? This will consider as a 0. If this is 0, this is positive 2 phi f and this is negative phi f. Both will get cancelled, means this total term will become 0. And as this term becomes 0, means these two are equal, means body without body effect, voltage is same. So in this way, you need to remember in your notes, whatever I have uploaded, I have mentioned minus over here by mistakenly. So just make it clear. So this is what is the final formula. Remember it. That is VTO. That is by considering body is connected to 0. This is the threshold voltage. This is the fabrication doping concentration factor. This is 2 phi f. Phi f indicates Fermi potential. VSB, whatever the voltage is applied to the bulb and source, in between bulb and source, and minus 2 phi f. This will get cancelled when VSB is 0. So hope you got the things clearly. So this is the thing, that body effect is the change in threshold voltage. It is the change in threshold voltage. Actually threshold voltage is this, but this is change in threshold voltage by amount approximately equal to change in source to bulb voltage. So I'm going to the next PPT. Now here same formula is mentioned and some details are mentioned. Just go through it. Same fabrication process and everything I have mentioned already. Now I told you in previous slide that whenever MOSFETs are designed, they are designed into one substrate, and different MOSFETs are designed like that. So there is only one bulb and there are suppose n number of MOSFETs, so n number of substrates are there. So to avoid this body effect, what we can do, because if we are connecting one bulb to all the sources, so it will create a useless circuit, as I explained you this particular thing. So what other things are there, that one could achieve different body voltage for all transistor by putting all transistor in different way. But this could that would means a tremendous penalty in terms of area of the area and the size of the transistor, and this is not possible, because if the size of transistor increases, means we can't tolerate that, or we can consider it. So we can't go for this, that for each and every transistor there should not be a different body. So this we can't go for this. So what we can do, that another thing, that what we can do is that first thing, just remember, to prevent latch up in CMOS, body source and body drain diodes should be forward bias, should not be forward bias. What is the meaning of latch up? Anybody can tell what is meant by latch up, or actually think of that particular thing? You are not able to tell, just think of that. So latch up means excessive current flow. Now suppose there are two diodes present over here, and if they are forward bias, what will happen? Instead of drain current, there will be different current also flowing, and this is not actually required, but which is present. So latch-up means excess of current flowing through the device. So for that, what you require, this diode should be reverse bias always. From the starting only, I just was telling you that these two diodes should be reverse bias. What is meaning of reverse bias? That this negative terminal should be at a positive side, and this positive side should be at negative. Means suppose this source is grounded, that is 0, and this bulk is also 0, means I can say this is not on, because forbidden gap is still there. 0.7 voltage is required to overcome that, and that's why this device is off. And here, if I am giving VDS positive also, what is happening? Plus means this makes your particular diode reverse bias. So in this case also, both diodes are reverse bias, and that's why current is not flowing. So meaning of latch up is that to avoid excessive current flow through the device. So that can be achieved by making both the diodes reverse bias. This condition will be satisfied if we connect all NMOS bodies to their respective source. What is the way out for this? If we are connecting source with the body. Now, if I am connecting source with the body, what will happen? This always we are making negative, and VDS, this is positive. So as we are making it negative and it is connected to this, means it will make this body negative. And this way we can avoid the body effect. Now, in this, what you need to remember, that always for N channel means there are two N plus doping. The body should be connected to negative. For N negative. For P channel or P MOSFET, body should be connected to positive, because I already told you all the notations for the PMOS and NMOS are opposite. VSD, in N MOSFET it is VDS or negative. So I already told you. So in this way we can say that body of N MOSFET should be connected to negative voltage, and body of P MOSFET should be connected to positive voltage, and it is connected to source. So here we can see this is the reason why all N MOSFET body is shorted. Is shorted with what? Source, and connected to ground. N with N means negative. And similarly, body of PMOS transistor is shorted to source and connected to VDD, means P with positive. Okay, if I am giving some positive voltage here, what will happen? Electrons which are forming the inversion layer will get attracted towards the body, and that's why you need to apply more VT. This effect is called as a body effect. Hope this particular point is clear to you. So it's time to poll question. So first poll question, due to body effect, what happened? So answer to this question is threshold voltage. I told you. So many of the students have given right answer. Only 1-2 students have given wrong answer. It's okay there. So hope you got the idea. So as VSB, you're applying certain voltage between VSB, threshold voltage changes. I told you previously VT was 0.6. Now it is increased because of that bulk voltage present. Okay. So next poll question, because it is not added over here, so I'm just taking it on screen only. Bulk of N and P channel, N channel and P channel MOSFET should be connected to. Case of body effect. So here from the starting only, I have shown this particular diagram that this source is connected to body. So to avoid the body effect, always this source should be connected to body. Again, this body and source which are connected together, this should be connected to the ground potential, because this is the NMOS, N for negative. So body is connected to the negative, and for P MOSFET it should be connected to positive. So these poll questions are related to your body effect. Now, bulk of P MOSFET should be connected to. It's not related to source or drain. It is related to voltage. You can put your answers in the chat box. So what is the answer for P? P for P, N for N. What is the meaning of this? P for P, N for N? P positive, N negative. This way also you can remember. Bulk of the P MOSFET should be connected to VDD. P for positive. So VDD is positive. VSS means here in MOSFET we are giving VSS as a ground. So just remember, for due to body effect there is change in threshold voltage. Threshold voltage increases. Bulk of N and P channel MOSFET is connected to source, and bulk of P channel MOSFET is connected to VDD. P for positive. In this way you just remember the things. So this is what is the summary. What is body effect? That is change in the threshold voltage by amount approximately equal to substrate source to bulk voltage. For N channel, here I have mentioned, just see this, N negative. What is the meaning of N negative? For N channel, body should be connected to negative voltage. It should be shorted to source, but it should be connected to negative voltage. For the P MOSFET, body is shorted, but body should be shorted to source, but it should be connected to positive voltage. So just remember in this way, N channel negative, P channel positive. What is negative? That voltage you need to apply to body terminal. Okay, so here it is mentioned, to avoid the latch up, this particular two diode should be reverse bias, so that there should not be any extra current flowing to the device. So for that, what you need to do, you need to make it reverse bias. So how to make it reverse bias? By making your this VB 0 and shorting it to the source. Now in case of this N channel, as this is the N channel, it should be connected to ground. But in case of P channel, when the dopings are P and substrate is N, and in this case, what you need to do, you need to apply VB as a positive, so that electrons will get attracted to the source and holes will get repelled and create the inversion layer in case of P type of MOSFET. And this is how you need to remember this formula. If I am putting VSB as a 0, means body is connected to ground, what will happen? This whole term will be 0, and that there is no effect of change in threshold voltage. But if the body is not connected to proper voltage, that is a negative over here, 0, so what will happen? 0.1 is present, so 0.1 will be get added over here, and some factor or some value you will be getting, that will be added in the VTO. What is VTO? This is the threshold voltage when bulk is considered as a ground. Bulk is connected to the ground. So hope this particular point is clear to you. So this is called as a body effect. Now, before going to the next thing, I already explained you what happens and when it is happening. So this is the concept, how you have recall the thing or events. So go to this particular link and just give your vote. N channel, if body voltage increases, I have given in the case of diagram 0.1 voltage, it should be 0, but I have given a 0.1. So what will happen if the body voltage is 0.1? Electrons will get attracted to the body terminal. I told you that electrons will get attracted towards the body terminal, leaving the inversion region, and that's why you need to apply more VT to create the inversion layer. And if the more VT is applied, that is VT is more, I told you it affects your ID, drain current decreases. So in this sequence you need to mark it. Okay, hope all of you got clear idea about this.